Hello, algebra students. This is Chapter 1, Section 2. The title of this section is Order of Operations. This should sound familiar to you, but just in case you're a little rusty, let's talk about what it means to evaluate an expression. It says evaluate the following expression. Well, to evaluate means to find the numerical value, find the number. We want the value all the way as simplified as you can get it. All right, so I'm going to look at this problem. Oh my, there's a lot of numbers here. 3 plus 2 is 5 times 3 plus 5. 5 times 3 is 15 plus 5. That's going to give me the numerical value of 20. Now, I hope that as I was working that problem, you said, wait, Mrs. Mitchell, you're doing it wrong, but I'm not there with you for you to tell me so. So let's do it a different way and see if we get a different answer. Which way am I supposed to approach this problem? Maybe I want to say, let's multiply before we add. So we'll take care of the 2 times 3 first, and that's going to give us 6. So now I have 3 plus 6 plus 5, which is going to give me 9 plus 5, and that one's going to give me a final answer of 14. Which one is the correct answer? That's the question. Well, there has been a set of rules that tell us in order to perform the operations. There's a rule about this, so both answers are not correct. We've used this system since the 1600s when mathematicians first started using algebraic notation. And this order is called the order of operations, the order in which they want us to perform the operations. First, if there's any grouping symbols, that would be parentheses or brackets. Also want to tell you that if you run across division where there's some operation going on above the division bar, and then there's operations below the division bar, the division bar also acts as a grouping symbol. You're grouping your numerator. Whoops, I meant to change color. Grouping your numerator, grouping your denominator, and then you divide. More to come on that as we encounter those problems. Okay, so grouping symbols. If there are exponents, you need to take care of exponents next. And then next to last, if there's multiplication or division, this is what I call they're equal in value. Division's not over multiplication. Multiplication doesn't come before division. And this is where it is so important that you pay attention and read from left to right in the problem. All right, and then now lastly, it's addition or subtraction. And these also are equal. It doesn't matter which one you do first as long as you are going again from left to right in the problem. So let's work a few examples so that you'll understand what I'm talking about. All right, we have 48 divided by 2 to the third power times 3 plus 5. So according to the order that we just wrote on our paper, the first thing I need to do here is take care of my exponent. So I have 48 divided by, and 2 to the third power is 8, times 3 plus 5. So here I have division, multiplication, and addition. So I am going to read my problem from left to right. Division comes before multiplication from left to right, and these are what we call equivalent in order. So 48 divided by 8 gives us 6 times 3 plus 5. So now between multiplication and addition, multiplication comes first, and 6 times 3 is 18, and 18 plus 5 is going to give us 23. Okay, for example B, we have a lot of parentheses. So we're going to start working from left to right. 8 minus 3 is 5 times 3, and then within those parentheses you have 3 plus 2. So it's going to be 5 times 3, and 3 plus 2 is 5. Now I'm working from left to right. This is multiplication. These parentheses now mean multiplication. So working from left to right, 5 times 3 is going to give me 15 times 5, and that gives me 75 for a final answer. Okay, there's some brackets in example C, so I'm going to start inside my brackets. And inside my brackets, there are parentheses, so I have to take care of my innermost parentheses first. So I'm just recopying everything except 6 minus 2, which is 4. So inside the brackets, I have 12 divided by 4. 12, remember, grouping symbols come before exponents. 12 divided by 4 is 3. Now I'm ready to say 3 squared, and that's 9, and 4 times 9 gives us 36. All right, here's what I'm talking about with the division. This acts as a grouping symbol. We're grouping the numerator and we're grouping the denominator. So in the numerator, I need to take care of 2 to the 5th power, and 2 to the 5th power is 32 minus 6 times 2. 3 to the 3rd power is 27 minus 5 times 3 minus 2. So now in the numerator I have 32 minus 12, 6 times 2. In the denominator I have 27 minus 15, and that is supposed to be a minus 2. My minus sign didn't get. Alright, so I'm finished with my numerator once I say 32 minus 12 is 20. And now I'm moving from left to right because I took care of multiplication. 5 times 3 was 15. These are both subtraction symbols. Check it from the original problem. Sometimes we get in a hurry and we make careless mistakes from not reading able to read our own writing. 27 minus 15 is going to give us 22 minus 2. So I end up with 20 over 20, and that's the value of 1. Okay? Now, to evaluate when there are variables in the problem, they need to tell us what the variables equal. So once we know the value of the variable, we can evaluate the whole operation. Alright, so it's 2 in parentheses, x squared minus y in parentheses plus z squared. So notice how I left every variable a set of parentheses. What was x? X was 4. What is y? Y is 3. What is z? Z is 2. So now this problem looks just like the examples we were working before. Where do I start first? Inside my parentheses. So I have 4 being squared inside my parentheses, so exponents come first within the parentheses, plus 2, which is also being squared. Then I end up with 2 times 13 plus 2 squared. So now I need to take care of the 2 squared, which is 4, and 2 times 13 is 26 plus 4 equals 30. Now the more we practice this, the more we can possibly have gone ahead and squared the 2 on this line, but I'm taking you through each step, following the order of operations to the T, so I do not make a careless mistake. And sometimes when my problem runs over like this, I like to draw a little arrow, especially in your homework. It'll help me to follow your work. Alright, so life isn't going to come to us with a string of expressions to operate on. Life's going to come to us in words. So let's tackle this word problem. Alright, so suppose you are an Egyptian historian. Each of the sides of the Great Pyramid at Giza is a triangle. The base of each triangle originally measured 230 meters. The height of each triangle originally measured 187 meters. The area of any triangle, is 1/2 the product of the length of the base and the height. So as you're reading all of those words about this pyramid and the triangles that are the sides of the pyramid, I hope that last sentence puts you at ease that they're going to tell us how to find the area. Part A says to write an algebraic expression. That means don't evaluate, just make up an expression that will represent the area. So we're focused on that last sentence first. It says the area of any triangle is 1/2 the product means to multiply, the product of the length of the base, and so they want that to be a B, the length of the base, and the product of that with the height, which they want us to use H. So that's the formula to find the area of any triangle. All right, so part B says to find the area of the Great Pyramid. So that means I need to know what the base is and I need to know what the height is. So the area of this problem, B, let's go back through all those words. The base of each of the sides was 230 meters, and the height, here's height, measured 187 meters. So first I'm going to take half of 230, 115 meters, times 187 meters, and 115 times 187, it's going to give us 21,505, and meters times meters is meters squared. Now as we work through more of these type of problems, hopefully you'll remember that whenever it's meters or inches, if you're doing area, they always end up being units of measured squared. So that's why, because we multiplied meters times meters. So if you get a little bit slack in actually writing the meter as you work the math, don't forget to go back and add your measurement whenever it's a geometry problem. All right, that ends our lesson for today. Have a great day.